Hello, my name is Matthew Randall. I am a biochemistry student at the University of Texas at San Antonio. Today, I will be showing you how to separate a 50-50 mixture of cyclohexane and toluene using distillation. We'll begin by gathering the materials. You will need a 100 milliliter round bottom flask, a stir bar, 4 Keck clamps, 1 bent adapter, 1 exit adapter, 1 distilling column, 1 Hempel column, a thermometer adapter, 3 vials, and 1 10 milliliter graduated cylinder. You will also need glass beads, a 50-50 mixture of cyclohexane and toluene, and 2 hoses. Begin by adding 30 ml of your 50-50 mixture of cyclohexane and toluene to your 100 ml round bottom flask. Add a stir bar. This is known as your distilling flask. When selecting a distilling flask, pay attention to the volume being added. Fill the flask more than halfway and you'll have undistilled products contaminating your condenser and fractions. Use too large of a flask and you'll lose much of your product to evaporation. Next, identify your Hempel column. It has 3 projections. Fill it 2/3 full with glass beads. Add the Hempel column to the round bottom flask. Tighten the clamp. Add the bent adapter and secure it with a Keck clamp. And the thermometer. And make sure that the thermometer goes just below the junction. Secure the skinny condenser. Add another clamp. Make sure that the inlet and the outlet are pointing upwards. Last, add the exit adapter and secure it with a clamp. Now you can set the graduated cylinder beneath to collect the distillate. Make sure your setup can be lowered in case the mixture gets too hot. Check the joints to see that they are a tight fit. Secure the hose to the water outlet and then to the lower projection on the skinny condenser. Add the second hose to the top and make sure that it runs to the sink. Turn the water on. Have your TA check your glassware before proceeding. Your TA will give you the appropriate temperature setting. Now that you've assembled your glassware, let's talk about the benefits and purposes of both distillation setups. Simple distillation is suitable for separating liquids with large boiling point differences. The substance with the lower boiling point will be distilled off first with reasonable purity so long as the boiling points have a large enough difference. Simple distillation takes less time than fractional distillation, and if need be, purity can be increased by performing a subsequent distillation on the purified product. Fractional distillation incorporates the use of glass beads and can be thought of as many separate mini distillations that increase the purity of the distillate. For fractional distillation, the liquids do not need to have large boiling point differences. As the temperature rises and the mixture starts to boil, condensation will collect on the beads and fall back down. The vapor and condensation on the beads will have greater composition of the substance with the lower boiling point. As time progresses and the mixture continues to boil, the vapor moving up the column will increase in purity because the substance with the higher boiling point is left behind to collect on the beads and fall back to the liquid. Like simple distillation, product purity can increase by heating slower for a longer period of time and by performing subsequent distillations on the collected product. Watch as the temperature rises and condensation appears. Make sure to collect and record the temperature as the first drop of distillate is collected. From then on, you will record the temperature every 2 mils. With your recorded data, construct a temperature versus volume graph. The first 10 mils collected are fraction 1. Pour fraction 1 into a labeled vial and proceed to collect the next 10 mils for fraction 2. Pour fraction 2 into a labeled vial and collect the last 10 mils for fraction 3. You will collect 3 10 ml fractions of distillate into 3 separate vials. Once the distillation is complete, you will determine the purity of the first and third fraction by GC analysis. Now you know how to perform a distillation. Thanks for watching.